Okay, folks, so good day to you. This is the second example. This is like example 1A, I guess, or 1B. So it says describe the transformation of f of x equals x squared represented by h of x equals x minus 1 squared plus 2. Then graph each function. So I've already started this one, so I put the parent function there, which is f of x equals x squared. So I used 0, 1, 2, and 3, and then also a -1, -2, and a -3. So I came out with my points. That's them there. Now, I wanted to take you through just an example of how you find the y value given whatever h values you choose to plug in. Okay, so here goes. So I wanted to start out with what would happen if x was 0. So I'm going to do h of 0, and that's going to be 0 minus 1 squared plus 2. So 0 minus 1 is just a -1. That's going to be squared, and we're going to add 2 to it because we have to start with parentheses first. Now we go to our exponent. This is the same thing as a -1 times a -1, and we're adding 2 to it. So this becomes -1 times -1. It becomes a +1 plus 2, and so we're going to start out at 0, 3. Okay, so at the origin we are already up 1, 2, 3. So we have a point there. Now I want to see, well, what happens. We know what happens at 0, 3. So let's look and see what happens at, let's see 2. Okay, how about that? Let's look and see what happens at 2. So I'm going to do h of 2. Let's see, I want to put it where you can see everything. So h of 2 is going to be 2 minus 1 squared plus 2. So once again, I'm going to have 2 minus 1. It's going to become a +1, and we're going to square that and add 2 to it. Well, a +1 squared is 1 plus the 2, and we'll have 3. So at 2, we're up again to 3. So let's see here. 1, 2. Let's see, up to 3. We have our point right in there. So let's see what happens between 0 and 2, because maybe our vertex is somewhere here. Okay, let's do that. So I'm going to do 1. Why not? Let's look and see what happens at h of 1. Okay, and there's really no rhyme or reason to how I do this. I just normally, like I said, I pick 0 always, and then I go in and I pick 1, 2, 3. If I'm not dealing with a quadratic, I'll pick a number like 5, but 5 squared is 25, so my graph is only a 10 by 10 here. So, you know, you got to deal with what you got there. So at 1, let's see what is happening. So we're going to do h of 1. And if you feel like you got this, go ahead. I won't be offended if you fast forward, Miss Gable, at all. Matter of fact, I won't even know if you do it, okay? So 1 minus 1 is 0. 0 squared is just 0. So this is 0 plus 2. And so at 1, we'll be up to a +2. So 1 and up to 2. Well, that lets me know that's my vertex. Okay, that is my lowest point of my parabola there. Okay, so what is happening? We have a parabola that has a lowest point here, and we can put in other points to see what happens on the outside. I'm just going to go ahead and do my sketch based off what I have here. So give me just a second. I'm going to sketch that out. Okay, so it's just not focusing like I want it to. Excuse me, I'm going to zoom in and see if maybe that helps a little bit. It's not the best, but hey, it'll do. You can see our parent function is here in the black, and then our transformation is here in the purple. So what I want to do is line things up kind of like how I did just a minute ago. And you know what? While I line this up, I want to tell you, I don't think we even addressed it yet. But Here we go. Hold on just a second. Okay, so that's our parent function. And here is our one that we're transforming. Okay, because I use this word and I may be getting ahead of myself, but something that you may want to put inside of your memory bank, and this is going to come up again and again. This is called vertex form, and why we call it vertex form, I left it out. This right here, this is known as vertex form. But here is why. Your vertex, your lowest point or your highest point, your maximum or your minimum, is going to be found by H, comma K. Okay, so H will tell you your X value, how far left or right, and K tells you your Y value, up or down. Okay, so if I was to compare this to the note that we had a little bit earlier, our K value in that's what I get for trying to talk. Hold on a second. I made a little boo-boo. That's all right. We fix it. It was +2 at the end. Okay, so our K value in this case, it being a +2, mean that the graph shift up 2 because it's greater than 0. So K in this case is 2. And then our H value, well, we have X and X, minus and minus, H is 1. So that means by definition here with my vertex form, then my vertex is going to be in this case at vertex. And I'm sorry, coaches, if I'm doing this a little bit ahead of time, but I think that it's important that we mention this, okay, since we have a vertex form equation right there. Okay, so our vertex is at 1, 2, and like I said, our horizontal, our H value, it was less than 0. It was actually equal to 1. Wait a second, I'm getting ahead of myself. Our H value in this case was 1, and 1 is greater than 0. So we ended up moving to the right. That's what I get for reading and writing and talking all at the same time. Doing too much. Doing the most over here. So if we were to describe this transformation as far as what happened from the black graph to what we have here in purple, and I'm sorry you can't see that too well. We had here a vertical shift or transformation or translation. Vertical shift or translation, and it went up 2 units. And then our horizontal shift, we go left or right with horizontal. So our horizontal shift is going to the right. I was about to write the word horizontal again, y'all. Excuse me. It's going to the right, just the 1 unit. Okay, so this is how you're going to describe your transformations there with your, let's see here, with your practice. All right, so there you have it. Kate, oh shucks, I'm writing my little heart out and it was off the camera. Oh my gravy, that's what I get. So vertical shift up 2 units and horizontal shift right 1 unit. H is 1 and K is 2. Okay, so if you have any questions about anything that you're seeing right now, please don't hesitate to ask us. That's what class time is for, okay? If not, hold on to your question and then bring it back to us tomorrow. We'll be here, hopefully. Okay, have a nice day.